Question 1. Right, I've written the coordinates of the points u, v, and w down here, and I need to show that that triangle has a right angle. So I'm going to find the lengths of each of the sides. So u, v, the length of that will be the square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. So that is the square root of 82. VW will be the square root of the difference between 10 and minus 7 and minus 3 squared, and the difference between 7 and minus 1 squared, which will be the square root of 164. And UW, the last side there, will be the square root of the difference between minus 2 and minus 3, so that's 1 squared, plus 9 squared, which is the square root of 82. So that's the three side lengths. If it has a right angle, that would mean that Pythagoras' theorem is going to hold. Clearly, if it has a right angle, the hypotenuse is going to be the longer side, which is VW. So let's just have a look and see if VW squared equals the sum of the squares of the other two sides. And indeed it does, because VW squared is 164, and that equals 82 plus 82. So UVW has a right angle, and that is the first part, part A, done. Part B, find the coordinates of the centre of the circle. Right, well, because that triangle has a right angle, the longest side of that triangle, which is VW, must be the diameter of the circle, because only a triangle in the semicircle would have a right angle. So I know that VW is the diameter, so I know that the centre of the circle is going to be the midpoint of V, which is 7, 7, and W, which is minus 3, minus 1. So to find the midpoint for the centre of the circle, I'm going to add the coordinates and divide by 2. So that's 4 divided by 2 is 2, and 6 divided by 2 is 3. So that is the centre of the circle. And part C, write down an equation for the circle. Well, I know the centre is 2, 3. Now, do I know the radius of the circle? Well, I know the diameter. I know the diameter is the square root of 164, so the radius will be half of that, won't it? The square root of 164 over 2. So the equation of the circle is going to be x minus 2 squared plus y minus 3 squared equals the radius squared, 164 over 4, which gives me 41. So the equation of the circle is x minus 2 squared plus y minus 3 squared equals 41. And that is question 1 sorted out. Question 2. I've got 3 points which lie on a circle, and I'm asked to find that AC is the diameter of the circle. Well, if AC is the diameter of the circle, then the triangle ABC must be a right-angled triangle, because triangles in a semicircle are right-angled triangles. So to take it the other way, if I can show that triangle ABC is a right-angled triangle, then the triangle ABC must be the triangle in a semicircle, in which case AC must cut the circle in half, and therefore AC must be the diameter. So what I'm going to do is I'm going to find the length AB, I'm going to find the length BC, and I'm going to find the length AC, and see if those lengths satisfy Pythagoras' theorem. And if they do, then it's a right-angled triangle. And if it's a right-angled triangle, then AC is a diameter. So to find the distance from A to B, I'm going to look at the coordinates of A and B, find the difference in their x coordinates squared plus the difference in their y coordinates squared. So that's the square root of 10. BC, right, looking at the coordinates of B and C, difference in the x coordinates squared plus the difference in the y coordinates squared. And that gives me the square root of 90. Now let's look at AC. The difference in the x coordinates squared, 6 squared, plus the difference in the y coordinates squared, that gives me the square root of 100. Okay, do these three side lengths satisfy Pythagoras' theorem? Let's see. Does AC squared equal AB squared plus BC squared? Well, does 100 AC squared equal 10 AB squared plus 90 squared plus 90 BC squared? Yes, it does. So AC is a diameter. Good. Part B. Write down an equation for the circle. Now, to find the equation of the circle, I'm going to need to know the centre of the circle. How am I going to find the centre of the circle? Well, the centre is the midpoint of AC because the circle is in the middle of the diameter. So I'm going to write down the coordinates of A, 2, 6. I'm going to write down the coordinates of C, 8 minus 2, and I'm going to find their midpoint by adding together the x coordinates and dividing by 2, and adding together the y coordinates and dividing by 2. So there's the midpoint, that's the centre of the circle. Now, do I know the radius of the circle? Well, I know the diameter AC is the square root of 110, so I know the radius must be 5. Right, now I've got the centre and I've got the radius, so I can write down the equation of the circle. X minus 5 squared plus y minus 2 squared equals 5 squared is 25. There is the equation of the circle. And for part C, I'm asked to find the area of the triangle ABC. Right, well, I know that ABC is a right angled triangle. I've got AC, which is the diameter, which is 10. I've got AB, which I know is the square root of 10. And I've got BC, which I know is the square root of 90. And to find the area of a triangle, I simply do the base multiplied by the height divided by 2. Well, that's going to be the square root of 900 divided by 2, which is 30 divided by 2, which is 15. And that is question 2 sorted. Question 3. Right, I've got 3 points that lie on the circumference of a circle. And I'm asked in part A to find the perpendicular bisector of AB. Right, let's write down the coordinates of A and the coordinates of B. Now I need to find the perpendicular bisector, so if I find the gradient of AB first, that will help me find the gradient of the perpendicular bisector. So the gradient is the difference, one y coordinate minus the other, divided by the x coordinate minus the other. So I'm going to get 8 over minus 12, which gives me minus 2/3. So that's the gradient of the line AB. So the gradient of my perpendicular bisector, which I'll call M2, is going to be the negative reciprocal of that. And my perpendicular bisector is going to go through the midpoint of A and B. So I'm going to find the midpoint of A and B by adding together the x coordinates and dividing by 2, and adding together the y coordinates and dividing by 2. So my perpendicular bisector goes through the point 315 and has a gradient of 3 over 2. Y minus 15 equals 3 over 2 lots of x minus 3. Multiply everything by 2. Multiply out that bracket. Let's write it as y equals, shall we? So it's going to be 3x plus 21, and then divide by 2, divide by 2. So there is the equation of the perpendicular bisector of AB. Okay, part 2, the equation of the perpendicular bisector of AC. So I'm going to write down the coordinates of A, which is minus 3, 19, and write down the coordinates of C, minus 15, 1. And I'm going to follow exactly the same process for this question. So I'm going to find the gradient of AC. So that'll be 19 minus 1 over minus 3 minus 15, which is 18 over minus 3 plus 15 is 12. So that is simply 3 over 2. Right, so let's think about my perpendicular bisector then. My perpendicular bisector will go through the midpoint. Minus 3 plus minus 15 is minus 18, divided by 2 is minus 9. And the midpoint, 19 plus 1 is 20, divided by 2 is 10. And it will have a gradient of the negative reciprocal of 3 halves. So its gradient will be minus 2/3. Y minus y1 equals the gradient multiplied by x minus x1. Okay, multiplying by 3, 3y minus 30 equals minus 2x minus 18. Let's write this as y equals, so y will be, so I've got minus 2x, I'm adding 30, so that onto the minus 18 gives me plus 12, and then I'm going to divide by 3, so y will be minus 2/3 of x plus 4. Okay, so I've worked out the perpendicular bisector of two chords, the chord AB and the chord AC, and now I need to find the coordinates of the centre of the circle. To find the coordinates of the centre of the circle, well, I know that those two perpendicular bisectors, the perpendicular bisectors of a chord, will go through the centre of the circle, and so I know that both of those equations, both of those perpendicular bisectors will go through the centre of the circle, so I can solve them simultaneously. So I've got y equals 3 over 2x plus 21 over 2, that's the first perpendicular bisector, and I've got y equals minus 2/3 of x plus 4, that's the second perpendicular bisector, and I'm going to solve them simultaneously. So I've got y equals this and y equals that, so this equals that. Okay, I'm going to multiply everything by 6. So that's going to give me 9x plus 63 equals minus 4x. That should be minus 4x plus 24. Okay, plus 4x to both sides, 13x equals minus 63 from both sides, minus 39. So x is minus 3. Good. So now I need to find out what y is. Well, I use one of those equations. It doesn't matter which. I'll use y equals 3 halves of x plus 21 over 2. So that's going to be 3 over 2 times minus 3 plus 21 halves, which is minus 9 halves plus 21 halves, which is 12 halves, which is 6. So the centre of the circle is at minus 3, 6. And that is part B complete. So now all I need to do is part C, which is to write down the equation for the circle. Right, how to find the equation for the centre, how to write down the equation for the circle. Right, well, I'm going to need to know the centre of the circle, aren't I? Well, I know the centre of the circle. Okay, I'm going to do this over here, C. I know that the centre of the circle is minus 3, 6. And I'm also going to need to know the radius of the circle. Now, I'm not sure I know the radius of the circle, but I know the centre of the circle, and I know lots of points which are on the circumference of the circle, so I can just find the distance from the centre to one of those points on the circumference. I'm going to use the point A. Now, the point A was minus 3, 19. So I'm going to find the radius of the circle, which is going to be the distance between the centre of the circle and the point A. Look at this. This is more obvious than I thought because they've both got x coordinates of minus 3, haven't they? So the distance between those points the radius is simply going to be 13. The distance between those 2 points is just 13 because they're both -3 along, so it's just the difference between 6 and 19. So the radius is 13, that was straightforward, and I know the centre of the circle there. So the equation of the circle is going to be x minus 3, x plus 3 squared plus y minus 6 squared equals the radius squared, 13 squared. And that is the formula that's the equation of the circle, and that is the question complete. Question 4. Okay, so I've got some points that lie on the circumference of the circle, and I'm asked in A part 1 to find the equation of the perpendicular bisector of PQ. Well, let's write down the coordinates of P, minus 11, 8, and the coordinates of Q, minus 6, minus 7. I need to find the equation for the perpendicular bisector. So that's obviously going to go through the midpoint, P and Q. So what is that midpoint? Well, I'll find the average of the x coordinates. They add up to minus 17. So the average is going to be minus 17 over 2. And the average of the y coordinates add up to 1. So that's just 1 over 2. So there's the midpoint of PQ. Now the gradient of PQ is going to be the difference in the y coordinate. So I'm going to do 8 minus minus 7 over minus 11 minus minus 6. Well, that is 15 over minus 5, so that is minus 3. So my perpendicular bisector is going to go through the midpoint and have a gradient, not of minus 3, but of a third. So what's that going to look like? It's going to be y minus a half equals a third multiplied by x plus 17 over 2. Okay, so that's going to give me y minus a half equals x over 3 plus 17 over 6. So if I add a half to that, it's going to be x over 3 plus, well, a half is 3/6, that's going to leave me with 20 over 6. So I can simplify that. So I get y equals x over 3 plus 10 over 6. Over 3, I beg your pardon, plus 10 over 3. And that is the equation of the perpendicular bisector of PQ. Right, next, the perpendicular bisector of QR. Okay, well, let's start by writing down the coordinates of Q, minus 6, minus 7, and the coordinates of R, 4, minus 7. I know the perpendicular bisector is going to go through their midpoint. Okay, well, I can immediately see that this is going to be a bit of a strange one, really, because the midpoint is going to be minus 1, comma minus 7. Why do I think this is going to be a bit of a strange one? Well, because Q and R both have the same y coordinate, don't they? So this is what's going on with this one. We've got, here's my coordinate axis badly drawn. I've got Q, which is at minus 6, minus 7, somewhere here. And I've got R, which is at 4, minus 7. So I've got Q and R. And I'm asked to find the perpendicular bisector of Q and R. Well, Q and R is a horizontal line, so the perpendicular bisector is going to be vertical. Okay, and it's going to cross the x-axis here, halfway between minus 6 and 4. So it's going to cross the y-axis at minus 1. So the perpendicular bisector of QR is simply going to be the line x equals minus 1. So there's no reason to do any more work on that one. That's the perpendicular bisector of QR, the line x equals minus 1. So now I can go ahead and tackle part B, which is to find an equation for the circle. Now, to find an equation for the circle, I'm going to need to know the centre of the circle. How am I going to find the centre of the circle? Well, I've got two chords, and I know the equations of the perpendicular bisectors of both of those chords. One of the perpendicular bisectors has that equation, and the other perpendicular bisector has this equation. So I'm simply going to find the point that lies on both of those perpendicular bisectors, because that is the centre of the circle. So I'm going to use my x equals -1, substitute that into my top equation. That tells me that y equals 3. So the centre of my circle is at -1, 3. Okay. I also need to know the radius of the circle, because otherwise I can't write down the equation of the circle. So how shall I find the radius of the circle? Well, the radius is going to be the distance between the centre, which is -1, 3. Write that one down, -1, 3. I better call that cent, just in case I confuse it with the point C, the centre of the circle, and any point I want to on the outside of the circle. So I'll choose the point R, which is 4 minus 7. R, which is 4 minus 7. So the distance between those 2 points is going to be the radius, and the radius is going to be the square root of the difference in the x coordinates, 5 squared, plus the difference in the y coordinates, 10 squared. So that's going to be the square root of 125. So now I know the radius and I know the centre, so I can write down an equation for the circle. It's going to be x minus a, which is x plus 1 squared, plus y minus 3 squared. That's going to equal the square root of 125 squared, which is, of course, 125. And there is the equation of the circle, and that is question 4 complete.